This video is designed to introduce you to the Chance Electronic Sectionalizer, designated the type CES. The video covers the main elements of application, operation, and restoration of the device. The electronic sectionalizer is a protective device which has built-in intelligence to discriminate between temporary and permanent faults. It can aid the distribution systems engineer in the improvement of system coordination. It operates in conjunction with a backup automatic circuit recloser or a reclosing circuit breaker. The unit is specifically designed for the protection of single-phase lateral lines, and when properly sized and installed, it virtually eliminates temporary nuisance-type outages. Your protection engineer will specify which rated unit is to be installed at each location. Your engineer will determine the number of counts to operation, 1, 2, or 3, and will also select the continuous current rating in amps, ranging from 5 to 200, as well as the actuating current, which is 160% of the continuous current rating. The number of counts and continuous current rating, along with the manufactured date, is stamped in the bronze casting at the hinge assembly. These numbers may also serve as serial numbers for record keeping and location monitoring by your personnel. The CES unit mounts in a standard Chance Type C cutout and also in the S&C Type XS cutout mounting. If the application is to replace an existing fuse cutout of these two manufacturers, then the electronic module, being interchangeable, will simply replace the cutout fuse tube. If the application is a new installation, then the mounting assembly and electronic module are installed as a unit using the same installation procedures approved by your company for installing cutouts. When properly installed and sized, the electronic sectionalizer is ready for its design protective function. For the Chance electronic sectionalizer to physically operate, 4 events must take place. The first event is fault current must pass through the sectionalizer at a current above its minimum actuating current for the CES to become active or wake up. For example, if the fault occurred at the location indicated, the fault current would only flow through the Tap 2 sectionalizer. Therefore, the Tap 1 and Tap 3 sectionalizer would continue to sleep, and the Tap 2 device would wake up. The second event the sectionalizer must see is a dead line caused by the upstream device. The CES detects a dead line by monitoring the line current to be less than 1/3 amp. If both 1 and 2 exist, then and only then will the CES count. The fourth and final event is when these counts reach the designated count, the device will operate. Going back to our original example, let's assume the fault current is high enough to trip the 4-shot single-phase recloser, and all of the sectionalizers are 3-count devices. Remember, the fault has just occurred and the CES has just been alerted on Tap 2. The next occurrence is the single-phase recloser will open and satisfy the second event, dead line. Notice the sectionalizers on Tap 1 and 3 still remain asleep. This is because event 1, overcurrent, was not satisfied. Since the Tap 2 sectionalizer has seen both events sequentially, it will increment its count by 1. When the recloser closes again and the fault is still present, the sectionalizer will see an overcurrent. The recloser will open. The sectionalizer will consequently see a dead line and then increment its count again. When the recloser closes in for the 3rd time and the fault still exists, the sectionalizer will see the overcurrent, then the dead line. The internal counter will increment to 3. Since the device is a 3-count device, it will immediately operate while the recloser is open and isolate the faulted line. When the recloser closes back in, Tap 1 and Tap 3 return to normal line current, and a service call will be required to repair the permanent fault. If the fault was temporary, the sectionalizer will reset the count it has in its memory after 25 seconds. When the CES operates, isolation is achieved by releasing a latch in the lower trunnion section of the module. A built-in current transformer provides power to an actuator, which releases the latch trunnion. This causes the module to swing down and drop open, similar to the action of a fuse tube. The open position gives a visual indication of the general location of the permanent fault. Now, let's look at several typical applications of the CES and how they will perform under fault conditions. The first application is protection of lateral lines. This is the example we have just discussed. The sectionalizers can all be of the same count, since the fault current will only be seen by one. Note that if all of the laterals were protecting underground circuits, the ideal sectionalizer would be a one-count device, since all underground faults are permanent. Another application is the use of sectionalizers on long, rural, single-phase lines. In this example, the line may be protected by a single-phase recloser set for 4 operations and 3 series sectionalizers coordinated by counts and amp rating. Each sectionalizer must be one less count than the upstream device as shown. When a permanent fault occurs at the location shown, only the 2-count device will operate because the 1-count sectionalizer does not see the fault, and the 3-count device will not reach its 3rd count to enable operation. After the 2-count device opens, the recloser will re-energize the remaining unfaulted section of line, and the 3-count device will reset itself to 0 after 25 seconds. The final typical application is on an underground dip pole with a 1-count electronic sectionalizer replacing the fused cutout. Because the sectionalizer is immune to inrush and has no fuse curve, it eliminates fuse misoperations when picking up heavily loaded lines and helps the protection engineer with coordination. Since underground faults are almost always permanent, the 1-count sectionalizer operates and reduces the repeated exposures of reclosing on the underground cable and transformers. The restoration process begins with locating and repairing the fault. When a sectionalizer operates, the probability is extremely high that a permanent fault exists. Always use your company's safe working practices for isolating and repairing the faulted circuit. After this is accomplished, remove the sectionalizer module so the actuator can be replaced. To remove the spent actuator, hold the sectionalizer module at the lower end, pull the insulated leads from the module tab, and unscrew the actuator from the lower end fitting. Next, install the new actuator in the threaded hole of the lower end fitting and tighten finger tight, making certain the end is flush with the casting surface. Over-tightening may damage the actuator, so do not tighten with a wrench. Place the insulated terminals over the tabs and firmly push them on until they stop. The insulated terminals should cover the tabs. Latch the trunnion in place by rotating it toward the lower fitting. The sectionalizer module is now ready to be returned to service. The used or spent actuator does not require special handling for disposal. Again, when a sectionalizer operates, the probability is extremely high that a permanent fault exists. Repair it and reinstall the sectionalizer. Do not use the sectionalizer to close in on a fault. If no fault is found after an operation, use your company's standard safe working practice procedures before closing. Do not attempt to open a sectionalizer to interrupt load current without using a load break tool or a mounting assembly with arc chutes. The standard mounting assembly is equipped with hooks for use with a load break tool. For applications where opening under load is frequent, a load break sectionalizer is also available. In this video, we have illustrated the sequence of operation, typical applications, and how to reset the Chance electronic sectionalizer. If you have any questions concerning these topics, please consult the factory. Studies support about 80% of all outages can be termed as nuisance or no cause can be found. A properly applied Chance sectionalizer can significantly reduce system operating costs by reducing the nuisance outages and by improving the system's coordination.